Okay, so this is the 2-1 notes for statistics and AP statistics. It's actually the same for both. We are looking at frequency distributions and graphs and measures of central tendencies like mean, median, mode, variation like standard deviation, and position like quartiles and stuff like that. This chapter, so there's a lot of actual math going into it. A lot of it can be done on the calculator, and when we get to those sections where the calculator needs to be done, I will have a Desmos and TI Inspire demonstration for those. So first we're going to start with 2-1, the frequency distributions. So a frequency distribution is a table that shows classes or intervals of data entries with a count of the number of entries in each class. So we really need to kind of break that down. There's several pieces of information here. There's classes, there's intervals, so we really need to do that. So the first thing we're going to look at is an example of a frequency table. Classes are the individual groupings, okay? And then frequencies is how many of numbers 1 through 5 was in whatever data set you had. So a class is set up usually between 5 and 20, or set up in groups of 5 to 20 groups. So there's 1, 2, 3, 4, 5, 6 classes here grouped in groups of 1 through 5, which is technically 5 individual numbers. So number of classes is how many groups do you have? How many numbers are in each group is called a class width. So the class width is determined by taking one class and figuring out what the difference is between the lower number on that class to the next lower number on that class. So 6 minus 1 gives us 5. So our class width is 5 numbers. So each group is including 5 data type numbers. So 1, 2, 3, 4, 5. That is 5 actual numbers that you would look for that would be counted as the number of times that you see them would be the frequency in that class. And every class has to have the same number of potential groups. Think of them as sample sets, okay? You want 5 sets of 5 or 6 sets of 5, but they're in terms of numbers. So for the class of 26 to 30, there are 2 classes. There's a lower class and an upper class. So the first number is called the lower class. The second number is the upper class. It is the highest and lowest numbers that can be in that group, okay? A range is figured out by taking the highest number, the max of that class of the classes, minus the lowest number of the classes. So 30 is the max number in this frequency chart. The smallest number is 1, and so we find the range by taking 30 minus 1. Now, when we want to create one of these graphs, range is actually our first thing we do. And then our lowest number will always be the lowest number in our data set. So we're going to be doing that throughout this a lot during this section. So there are some steps that we will use to create these frequency steps. You do need to copy all of what I've got on this page. I know I've got it set up as a worksheet, but unfortunately we have to copy it down by paper. I have done this on hand. It is not that much writing. It just looks like a lot. Make sure you copy all of the steps because you have to follow these same steps all the time. So determine the amount of classes you want. We want between 5 and 20. You don't want to go more than 20 and you don't want to go less than 5. The reason for that is because if you do, your data, your groupings of in each class will be either too small to be significantly making any sense, or it will be too big to make any sense. So the less number of data points you have to start with, you want to stick with smaller groups of things. If you have like a couple thousand data points, then you would do groups in bigger groups and more classes. So then you would find the class width. We do that by finding the range of your lowest number in your data, biggest number in your data minus your lowest number. So this is going to be biggest data point minus lowest data point. So that's your first step. You find that. Then you divide the number of classes you've chosen by that range by that number of classes. And that is your class width. So class width equals range divided by number of classes. Okay? So then you want to find the limits. The limits are the minimum data point, which is where your lower point of your first class will be. And then you will add your class width, that number you just found a minute ago, to that lowest data piece. Okay, and I will demonstrate this whole setup as we go. And then you would, and then what you're going to do is you're going to subtract 1 from the number you get as your next class to get the upper of the previous one. And then you'll use tally marks to figure out the entries in that data. And then you will count the tallies to find the frequencies for each class. I need to pause. Why does this thing hate me so much? Come on, pause already. Okay, so I'm going to show you an example of how to do a frequency distribution. I do recommend that you follow along at the minimum, write down your steps, maybe create a smaller sample set, maybe half the numbers or the whole thing. But basically, this is the idea of what you're going to do. So the first thing we want to do is to state the number of classes. And it actually tells us that we want 3 classes in here. So our number of classes will be 3. Then we want to locate our minimum and our maximum entry. So our minimum entry, if you look through all of the numbers, is 42. That is our min. Our maximum is 58, or excuse me, 68. That's our max. And so now we need to find our range. So the first thing to remember is that range is the class width is equal to the range divided by the number of classes, which again, our range is our max minus min. So we're going to do 68 minus 42, and then we're going to divide that answer by 3, which is equal to, in our calculator, of 8.66. And then we want to round up. Always round up to the next whole number. Always. Doesn't even matter if you normally would round down. That's the only time when math, our old rules don't apply. In fact, if our number ends up being a whole number, like it was, say it had been just 8, you would actually still go up to 9. You always go up to the next whole number. Okay. Next, we want to start our class. Well, we start our class with our minimum. So you're going to start your class, find the max and min, find your class limits. And the class limits is what we're doing right now. We're going to find the lower limit and the upper limit. So we're going to start with our lowest number. And then we're going to add on to that number our class width. So we're going to add 9. And we can think of this as being on the outside to know what we're doing. So we're going to do 42 plus 9, and that's going to give us 50. Sorry about the phone. That's going to give us 51. And then we'll do it again, and we'll keep doing that until we have enough classes to cover everything we need. So 51 plus 9 gives us 60. That gives us our lower class. All right, now we need to do our upper class. Upper class is easy, really easy. We just need to subtract 1 from our previous thing. So we're going to take our next class, we're going to subtract 1, and that's going to tell us what our new class, our next, the upper is from the previous class. So 1 away from 50 is, 51 is 50. And then we can do the same process that we did on the other side. We can just add 9 each time. So 50 plus 9, 59, 59 plus 9 gives us 68. So the processes are going to be the same for the upper and lower. The only additional thing you do is you take your the second class, subtract 1 to get the upper of the previous class, and then you start adding your 9s down. Okay. The next step is you're going to do your tallies. We're going to tally up the numbers that go between 42 and 50, 51 and 59, 60 and 68. So I will get that started, and then I will show you what it would look like at the end. So first, what I would suggest doing is just start on the left and move all the way through your numbers, making your tally marks as you go. That's why we do a tally chart, because that way we don't, instead of trying to go through and go, well, I see between 42 and 50, I see a 50 or 49. That's 1. There's 2. There's 3. You will make errors on your frequency if you try to go through the numbers without making your tally marks. So as you do your tally marks, I suggest you go ahead and cross them out. So 57 would go between 51 and 59. I'll do down and then across. 52 would be between 51 and 59. 61 would end up being in the third group. 56 is in the second group. Now I'm color coding them just to make it a little easier. And when you're done, you're going to end up with your tally marks for 42 to 50, and then you simply count up your number of tally marks. There was 5 plus 3 gives me 8, and that tells me my frequency for that class. Between 51 and 59, there was 5, 10, 15, 16, 17. And then from 60 to 68, there's 5 plus, so 5. And then you would want to add up your frequency. 8 plus 17 plus 5 should be the sum. This symbol here that looks like a very fancy E means the sum of. That means add everything in that column up. You should have the same number of ends, n being your number of data points, as you have as your frequency total. If you may end up with a different number when you add this column up than what your frequency total was, then you made a mistake when you did your tally marks. Okay, so that's how you'd create a frequency table. Now we're going to look at a couple of more definitions, important definitions. We're going to look at the midpoint. A midpoint of a class can be found by using the formula, the upper class limit or lowest class limit plus the upper class limit divided by 2. So for our example up here, 60 plus 69 divided by, or plus 60 plus 62 divided by 2 gives us a midpoint. And we'll look at that a little bit here in a second. So it tells us what's the number that's halfway between our group of numbers. That's what midpoint means. Relative frequency is the proportion or percentage of the data that falls in that. And so that is your class frequency, the 8, divided by the number of people in your whole data set. So 8 divided by 30. Cumulative frequency is like think of a cash register. It is the adding up of each step until you get to the grand total. So when we did 8 plus 17, you were actually doing the steps you would do for cumulative frequency. So 8 plus 17 is 25, 25 plus 5, that's 30. That is the steps for cumulative frequency. And I'll show you how that works on an example. So let's look at an example all filled out. The first 2 parts are copied down. So what we're going to do is copy down our numbers, 42 to 50, 51 to 59, and then 60 to 68. And where frequency from our previous example stays the same, and the sum stays the same. So that part stays the same. Now we're going to do the midpoint. Midpoint is you take your 2 classes and you add them up, 42 plus 50, and divide by 2. and that will tell you your midpoint. Now, here's something very important. Remember we added 9 down between each one of the classes, the class width? Once you figure out your first midpoint, you can use that same trick. You can add down 9 and it will get you the midpoint for all of the following. So you really only have to do this midpoint situation one time, as long as you don't make any errors. So 42 plus 50 divided by 2 ends up being 46. And then we add 9 to that and we get 55. We add 9 to that and we get 64. The reason why we want a midpoint is because if we're looking at a bar graph or something, or we're doing some other future math that we have to do for this, we'll be using the midpoint. Now, here's something to key. Class and midpoint are related data. Anytime you see the word a bar, one of these tables, you're looking for related words. Any of the columns that say the word frequency in them are related to, and only use the frequency column. All other ones only use the class column. Okay, so those are related. Now for frequency distribution, a relative frequency, we take the frequency for that column or that row divided by the n, which we have down here. This is your n. And that is going to be a decimal. So we're rounding usually to 2 or 3 decimal places. So that's approximately 0.2027. And then we do that for each one of the groups to get our numbers. And I have already pre-written these out, so I already know the answers, but you would use your calculator. Now, here's the key. This one must always be equal to 1. Now, if it adds up to 0.99, that's usually close enough. That's a rounding error, but it should always equal to 1. Okay? Cumulative frequency is like that cash register idea. So you go up to the cash register and they scan the first item. So the first group comes in, 8 people walk in. Now you have 8 people in the room. The second group comes in, 8 people are already in the room, but we're going to add 17 to it because 17 more people came in, and that gives us our people in the room at that point. The door opens again, 5 more people come in, and we get the whole group in the room. Okay? So that's how you would actually do cumulative. It's actually like a cash register, adding in every time something is bought, you add to the previous total. Okay, and then for the pattern, so we want to look over half of the first presidents, because they were talking about presidents here, were between the ages of 51 and 59. So between 51 and 59 years old, 57.57 or 57% were over the age or at the age of 51 to 59 when they were inaugurated, in other words, became president. Okay, so that's a way to get organization. All right, now that we have a frequency table, we are going to create some graphs with them. So the first type of graph we are going to create is called a frequency histogram, which is just a fancy name for a bar graph, only it's a very special bar graph. It's a bar graph that represents the frequency of distributions of the data. And it is really important that we make sure that we label our table graphs correctly. So when you're doing assignments, you'll be wanting to make sure for the AP students, when you're creating these, you need to make sure to do your labels properly because that's important for the test. Horizontal scale, the x-axis is the data values, or also known as the classes. So this is your data. So this is also your classes, or it could be your midpoints. So it's either one of those. That's what you would normally have. The y-axis is the frequency, is it how many was in that group. So it's either going to be one or the other, okay? So there's a couple of ways we can do this. We can use the class to label the x-axis. We can use what we call we can use the midpoints. But when we're creating them, we need to figure out the class boundaries. And to do that, you take half of 0.5 away from the lowest and add 0.5 to the biggest. So you're basically taking away from Peter and giving it to Paul. So we're going to take it away from 0.5 away from 42 to figure out what the lowest possible error area is. And then we're going to add it to 50 so that they're connecting. The idea is that when we're done, all of these will end up being connected. So if you notice, the lower of the next group, when we take 0.5 away from it, it's the same as the upper from the previous group, and so forth, okay? The frequencies won't change. That has nothing to do with it. That comes off of our table. What we're doing is allowing ourselves to create our scale so that the bars themselves will connect and be and overcome any kind of error that might have happened. So we're going to be marked by either the class boundaries or the midpoint. So you may have 41 to 51, 50.5, 59.5, or you could have put a tick mark in the middle of these and marked them with their midpoints. Okay. The vertical scale would be counting by something that would make sense for for what your data points for your frequency. So between 0 and, in this case, 24, because of the number of lines that we had, and counting by twos, because if we'd only counted by ones, 17 wouldn't have fit onto the scale. Now you do want to make sure to have a title. So you want to make sure to have your title relate to the question. This is number of presidents at age groups, or something like that. Something that will be related to the actual question, and you should say at inauguration. Okay. And then you want to make sure to label your x-axis and y-axis so that it is very clear what these numbers on the x-axis are representing, what are the y's representing. And then you would distinguish the same patterns that you saw. 17, the majority of presidents are in the 50.5 to 59.5 age range out of all of the presidents that have been inaugurated. Okay, so the next one that we would use is called a frequency polygon, which is also just a form of a line graph. Okay, it's a line graph that emphasizes the continuous changes in the frequency. So it's looking for change. We would use the same kind of system to actually determine our x and y's, but this time we're going to make our midpoints our x-axis, and our frequency is still going to be our y-axis. To do that, again, we have to take our classes, we find our midpoints, which we talked about already, and then your horizontal scale, you're going to use the midpoints for the tick marks, and the frequencies are going to be the same frequency. And we would put a dot on the graph and label it with the frequency so it's very clear. Sometimes that doesn't work at that point. And what the idea is that this allows us to see that there is a big change in the number of people that number of inauguration or presidents from the age of 46 to the age of 55. And there's a big drop in the number of presidents that have been inaugurated over the age of 55. Okay, so that gives us a pattern. The next one is called a relative frequency histogram. So again, the word frequency is the key to what your x-axis, what you're looking for. You're looking for relative frequency, so that tells you what kind of data you're going to have on there. And again, this is a bar graph. Okay, so on your x-axis, you're going to use your data values, the classes, the same as your histogram. You're going to set it up the same way for your x-axis as your regular histogram, but your y's are now going to be the decimals that you figured out, the percentages. So again, you can either use your class boundaries or your midpoints to label, and then your relative frequencies would be on the side. So instead of being 1, 2, 3, 4 or 2, 4, 6, 8, you're going to use 0.1, 0.2, 0.3, 0.4, whatever works best for it, all the way up to 1. And then you would have your bars. And again, you should be able to look at this and say 57% of the presidents that have been elected or inaugurated are between the ages of 50.5 to 59.5. So that would be your pattern that you would be talking about. And then the final one is called a cumulative frequency graph, or an OGIV. Okay, an OGIV tells the growth, not the distance between. So on the previous line graph that we had, we were looking at 8, 17, 5. These are exactly how many presidents have been elected in the range of 46 years old. 17 at 55 years old, 5 at 64 years old. But this one tells us how many presidents have been elected over time. Okay, so basically, it's saying at the first age group, 8 people were elected. The next age group, or the next midpoint of ages, there was now a total of 25 elected presidents. And then at the top of the list, there was 30 elected presidents that were up to 68.5. So between 50.5 and 68.5, 30 presidents. The top of the OGIV always tells you the sample size for that sample. There's not a whole lot more information it can give, but it does show growth. Okay, so that is all the different types. If you would like a copy of these notes, they are going to be in Schoology as a PDF. That way you can copy them and create the graphs. I suggest you do the graphs on graph paper. And if anybody needs a actual blank version of this particular one, please let me know, and I will try to do something for that. Stop.